Good morning, everyone. I'm Sravani, working as a senior software engineer for Azure database for MySQL and MariaDB engineering team. I have been working with Microsoft for last 13 years. Today, I'm going to present about Azure database for MySQL, the new offering that we have, which is a flexible server. So the objective of this session is I will walk you through the single server overview and the single server architecture and challenges, flexible server offering for MySQL, and choosing the right deployment option. And we will also cover the migration techniques that we have for flexible server or even single server for MySQL Azure DB. I also have some demos where I'm going to show you how can you deploy a flexible server and how fast you can migrate your databases, right? So today we have two deployment options for MySQL Azure DB. One deployment is a single server MySQL Azure DB, which is GA for last 3 years now. And we have a new offering, which is a flexible server, which is in preview currently, and we are expecting it to be GA soon, right? So the single server MySQL is best for a broad range of transactional workloads and web applications, while the flexible server is best for applications that need maximum control, advanced customization, and cost optimization. So let me quickly walk you through the architecture for the single server. So if you see, the MySQL database runs as a management service in a secure server containers, and we have our data which is located on a premium storage with 3 copies of data maintained within the Azure availability zone. And your applications will be connecting to the MySQL instance through the gateways. So in case if there is a failure with the compute where the server is running inside the container, we will automatically spin up another container and map your data and log files, and your application can redirect the connections to the new secure container. So this way it comes up with a built-in high availability and handles any kind of failures that you might have at the compute level. At the same time, since we maintain 3 copies of data, even if there is something goes wrong with one copy of the data, you still have 2 more copies with which we can quickly redirect the connections and you can bring it back online with very minimum downtime, right? So if you talk about the key features for a single server, one, it comes up with a built-in high availability with a resiliency for compute failure up to 99.99% uptime SLA. And it also has availability zone level resiliency with storage failure up to 3 copies. It is scalable. You can have up to 5 read replicas. It comes up with built-in monitoring, performance insight, and query store. It also has a built-in auto backups with a retention of minimum 7 days up to 35 days. And you have an option to stop the database if it is not in use. This is the best one when you have a development workload where you can simply stop the database and you don't have to pay for the compute when the service is off. So this is basically built for high availability, elasticity, security, integration in ecosystem, and it's an industry leading TCO. It's generally available from 2018, and we have seen significant growth year on year. And we have many customers who are tier 1 customers having their workloads running on the single server, right? So the single server comes in these 3 compute options. Today you have basic, general purpose, and memory optimized. And each compute option has different resources attached. Like for example, you can choose the number of vCores, the memory, storage, IOPS, backup retention and the backup storage, whether you want to have a locally redundant storage or a geographically redundant storage. So based on your workloads and based on your application, for example, it's a light compute and a variable IO performance, you can simply go for a basic compute options. If you have a business workloads and you want to have a memory with scalable IO throughput, you could go for general purpose. And if you have a heavy transactional systems where performance matters the most, you can definitely go for memory optimized VCUs, right? So these are the different flavors that we have today for single server. And based on the experience and learnings from our customers for the last 3 years, we have seen there are certain limitations uh, which we might want to address to make it a better product. So some of our SQL single server learnings from MySQL Azure DB is the first learning is the application latency. So if you see here today, you might deploy your application and the MySQL single server database in any of these deployment options, right? If you look at the first deployment option, most likely your application, your database, and your storage, everything is deployed within the same data center, which is basically an optimal deployment where you might have a less latency because everything is running within the same data center. However, there is a possibility that you might have your application running in one data center while your database and the storage is from the other data center, and your application has to connect through the great gateway to the database service, right? So this is like a suboptimal deployment where there is a delay because you have to talk from one data center to the other data center. And then the worst case would be you have your application running in one data center, you have the database service running in another data center where your compute is sitting, and then you have the storage which is running on the other data center. So if you look at this one, the connections for single server has to go through the gateway, right? And there is no co-location of the application. So no availability zone locality or choice. And there is a possibility that once you deploy the service, if there is a replacement for the compute, it can change due to scale operations or any other failure. So we cannot guarantee the co-location of the application with the database service in the same availability zone, right? So this induces certain kind of latency for your applications. And the learnings that we have is we want to eliminate this gateway so that we can reduce the latency, and we want to provide you availability zone co-location with the application, which will help you to a great extent to reduce the latency from the application side, right? And the second learning is with respect to the connections. So this is how the connection string would look when you are connecting to a single server database, right? Whether it is MySQL or PostgreSQL database. If you look at the user, you have to explicitly specify @host name, which is kind of challenge for many of our customers where during the migration, you might have to end up making a lot of changes in your application connection strings. So this is one of the key learning that we had, and we want to remove this explicitly specifying @host name. And establishing a new connection is expensive, and there is a hard limit for the number of connections per SKU, right? So the number of connections are tightly coupled with the SKU that you are using. So you might have applications which need more number of connections, but at the same time, you don't want that much of compute. So there is a learning for us. We wanted to decouple this number of connections from the SKU, and also want to reduce the time that we need to establish the new connection. And we wanted to remove @server name from the connection string so that you don't have to do a lot of changes during your migration. Third learning we have, which is most important learning for us, is from the monthly maintenance window, right? How the maintenance works for single server today is there could be multiple changes that are batched together and pushed to minimize the interruptions, and these maintenance activities happens once in a month, and there could be changes with respect to OS level, or it could be hardware level changes, or it could be some changes with the database itself, and all the changes will be pushed together as batches, and this maintenance happens probably once in a month, and customers will be notified in advance with 72 hours notification. However, customers doesn't have any choice to pause the maintenance, right? So, and this maintenance window is for 15 hours. When I say 15 hours, it's not that the service is not available for 15 hours, but the patch can happen anytime in this 15 hours. And there could be a couple of restarts or multiple restarts based on the patches that were pushed. And during that time, there could be a downtime of some minutes or several minutes to probably few seconds to several minutes, right? So the challenge here is if customers has any kind of ETL loads that are running, even though you are notified in 72 hours in advance, you still have to wait for 15 hours. Probably if you are scheduling something which is like a production job, you may have to skip the schedule for that day where the maintenance is going to happen, and that could be a challenge for certain applications which are running 24/7, and you have ETLs which are running over the across the week, right? So we also, for a 0-day vulnerability, we also reserve the right to initiate the maintenance without 72 hours notification. So these are the this is how it works for the single server, and the challenge that we see is customer has very limited control on this, and like I said, there is no way you can pause, and you might have to reschedule your production or any ETL jobs that might be running on that day. So from this, what we learned is we should provide customers full control, a customer control maintenance window so that they can better schedule their jobs or their applications or anything that is important during that day of the week, right? So this is another learning that we had. Now, coming to the next one is, like I mentioned, the single server comes up with a built-in high availability. So customer has to do nothing. If whenever there is a failure in the compute, we automatically spin up another secure container, and we attach your data files to the new container, and application can just redirect their connections to the new secure container. So this basically comes up with a built-in HA. And even if there is a failure at the storage level, since we maintain 3 copies of the storage, we still have 2 copies which are intact, and there is absolutely no data loss when there is a failure at the the storage level, right? However, if you see, the challenge here is if there is a failure at the availability zone itself where the storage is provisioned, that can lead to a downtime because all the 3 copies of storage that we maintain are within the same availability zone for now, right? So in case if there is a failure at the availability zone, which is a possibility to happen, right? So then there could be some unexpected downtime that could happen. So the learnings for us from the existing built-in high availability is provide availability zone selection and provide availability zone resilient high availability with automatic failover and with no data loss. So after having all these learnings, here comes the offering for MySQL, which is a flexible server offering. And if you look at the flexible server architecture, so one, now the service runs on a Linux VM. If you remember, the single server runs on a secure container inside the server, while the flexible server runs on its own Linux VM. And there is a change in the underlying operating system as well. We use Linux operating system for the flexible server, and we have a premium remote premium storage which is attached, where your data and log files are located, and we have a backup storage, right? So now you have your availability zone where your application is running. It could be running from Azure VM as an IaaS environment, or it could be running from AKS, which is like Azure Kubernetes Service, or it could be just running as an app service somewhere in the cloud, which is sitting in the same availability zone. And they can directly connect to the MySQL. If you see, there is no gateway here to make the connections, which would help you to reduce the latency. And the storage is a remote premium storage that is available, right? So this flexible server comes again in three offerings, right? One is burstable, general purpose, and memory optimized. So if you see some of the key changes here, one is the backup retention, which is for single server, it was 7 days minimum. And now we provide customers more control. If they don't have to keep their backups for 7 days, they can choose any number of days that they want. So minimum is 1 day to maximum 35 days of backup retention. And if you see the IOPS, there is a variable IOPS. I'm going to talk more about it in the upcoming slides. This is going to help a lot based on your workloads that you have for your applications, right? So based on what kind of option you choose, like a burstable or general purpose, you might get into a different VM series that you can choose. So what exactly we are trying to achieve with this flexible server for MySQL is basically we are trying to address the single server pain points that we have learned from our customers. One, the latency, we want to remove the gateway and then provide availability zone co-location so that the latency is going to be low latency. And for the connections, you can configure up to 5,000 connections, which means we have decoupled the number of connections with the compute. So you don't have to worry about paying more for the compute just because your application has to spawn more number of connections. And though you don't have to use @server as part of the username. And for the maintenance window, now we ensured you have an option where the customer can control the maintenance window. Availability zone resiliency with zone redundant high availability and improved out-of-box performance. So I'm going to quickly walk through these enhancements. So first of all, customer will have maximum control of your databases, because now for your flexible server, you can choose the maintenance schedule. It could be system managed schedule, which is a default one for single server, or you can go for a custom schedule. When you are opting for a custom schedule, from 15 hours of maintenance window, if you remember, now the maintenance window becomes just 1 hour, while in that 1 hour, the actual or the real downtime is going to be less than 60 seconds, right? And the next maintenance only happens once again after 30 days. And also about the notification, for single server, it was 72 hours notification. And for flexible server, it's 5 days advanced notification. So customer has full control to choose which day of the week, which hour of the day they want to apply the patches, and okay to have a minimum downtime which is less than 60 seconds. So customers now have full control on the maintenance that happens once in a month. And coming to the network isolation, so now when about the network connectivity for flexible server, again you have you can connect to the flexible server using two ways. That is, one, the public access. which is restricted by the firewall, right, which is the default one where your public IP addresses are exposed to certain number of IPs where you add the firewall rules from your application and client applications and make the connections through the public IP addresses, which is, we would say that not very secure. So the second thing is we have introduced for the private access, there is something that we can do with flexible server is having a virtual network. So you can have your own virtual network deployed in Azure cloud and have all your applications along with your database service running inside your virtual network, right? So you can simply inject your flexible servers to a delegated subnet and all your applications within the subnet can talk to each other. And if you have any applications which are running on premise, they can connect through either an express route or a VPN. So this is an enhancement that is done at the network level to avoid any kind of discrepancy by exposing the public IP addresses for your database service. And the customer has more control about the server parameters. You can configure a lot of parameters based on your requirement. It could be something specific to auditing, it could be bin log related things. So based on your workloads, based on your experience or based on your past learnings, you can tune these parameters based on your application requirements. So we have added more parameters which customer can control on their own. And here comes the best part of it, provision additional IOPS. So if you look at the compute size, so for every compute size, you have a storage size and IOPS, and the IOPS are variable IOPS here. And the best part of it is you can increase or decrease the IOPS based on the workload, which is like a great thing, right? Like if you have workloads which are very random workloads, right, you will have a high workload during certain part of the day, and then rest of the day your server is pretty much idle. Those kind of scenarios, when you know your pattern for the workload, you can simply expand your IOPS during that time and then decrease when it's not necessary. And all this can happen on the fly. You don't have to worry about having any downtime or restarting, so you can just do it from the Azure portal itself, right? So this is the best part of flexible server. And during my testing, I really loved this feature, right? I was testing some kind of performance for backup, restore, or some kind of queries. And I can just play with IOPS by increasing and decreasing and see how that's affecting my workloads. So this is something that is really a good thing. And then the storage size always complements the IOPS limit. So you can have minimum to maximum IOPS based on the workload that you have. And next comes the availability zone resiliency. If you remember with the single server, we had a single point of failure where if there is a failure at the availability zone itself, you don't have the data, right? So which can create some kind of downtime. So with flexible server, we introduced something called a zone redundant high availability, which means you can have your standby server, which is like a DR replica, which is running in a different availability zone. And there is a synchronous replication that happens between your primary replica and your secondary or the standby server. So whenever there is a failure at the availability zone level, if there is something that goes wrong on the primary side, you can simply switch the connections to the secondary server, which is sitting on the secondary availability zone. And you can, once your primary replica is back online, it will join as a standby and the synchronous replication will continue to work, right? So this is a zone redundant high availability, which means it will help you further not to have any single point of failures, right? So all you have to do from the application is just switch your connections to the new server, right? So when you enable this high availability where you have this zone redundant high availability, what what happens is there is an automatic failover to the standby during any unplanned outages. There will be a zero data loss after a failover because it's a synchronous replication. And you can also reduce your downtime for the planned maintenance operations, because now that you have a standby server, you can first upgrade your standby server, fail over your applications to the standby server, and then do the patching of your primary server. So this will help you to reduce the downtime for your maintenance activities. And you have a synchronous standby replica continuously up to date running in a different availability zone. And high data resiliency with physically separated synchronous copy of data, right? So now that we know what all challenges that can be addressed with the flexible server and what kind of uh, custom control that you can get with respect to changing the server parameters or the maintenance window or increasing or decreasing the IOPS. Now that you know what is best to choose, let's quickly talk about how can you migrate your database for MySQL, right? You could be running your databases either uh, on-premise or any other cloud environment, or it could be running within IaaS Azure VMs, and you might want to migrate your databases to MySQL. And when it comes to migration, it could be migration to single server MySQL Azure DB or flexible server MySQL Azure DB, right? And for any migration, there are three phases that happens. One is the pre-migration, and then the migration itself, and the post-migration. So in the pre-migration phase, that is where you have to do most of the work, where one, you need to discover, right? Discovering your existing databases and discovering your existing applications, what kind of dependencies that you have, if there are any limitations that you need to address, if there are any compatibility issues that you might have with the application. So during the phase of discovery, you have to do all this work and come up with the list of actions that you might have to address before the migration. So once you discover and assess the databases, you want to migrate the schema, and during the migration, you want to migrate your databases. So there are multiple options, like you have offline migration and online migration. So most of the times customers might choose offline migration when it's not a 24/7 application. They are okay with certain downtime, or if they are just migrating their development or test workloads, they can simply go with an offline migration, where for offline migration, all you have to do is just dump your database and restore it, the database, and bring your applications online on the cloud. Or for online migrations, we have you have to go for replication, logical replication, right, where you do an initial dump and then configure the replication between the on-premise or your database service and the cloud, and ensure your database is up to date, and you can just promote the replication, promote your database as a primary once you have a maintenance window that is approved, and once you have everything that is tested from the application end. And the post migration, that is where the optimization comes into the picture, because for every migration, most of the times, some of the common complaints or issues that we see with customers is having some kind of performance latencies, or something that stops working. I mean, even with a lot of testing, there could be a possibility that there could be something that is not working as expected. So basically, there is a piece of optimization that happens post migration, where you might have to tweak certain server parameters if something is missed during the migration and stuff like that. And then also you may want to explore the new options that you have with the cloud service, where probably you are monitoring the performance, you are getting some kind of query insights from the query store, and probably you can make your queries run better than what they were earlier based on the recommendations that you might be getting from the query insights. So yeah, that is a lot of work that you might be doing, and that will be from the learnings that you might have post migration, right? So what are the options that you have? Like I mentioned, either you just do a dump and restore for an offline migration, or you also have a database migration service which can be used for the database migrations. And we also use native data in replication that comes from MySQL for all online migrations. So what we basically do is first we discover you have to discover your databases and applications that are ready for the migration and assess your databases just to ensure there are no limitations. For example, one of the limitation is the tables that you want to migrate to Azure Cloud. MySQL has to be on InnoDB storage engine. So you might have databases where some of the tables could be running on a different storage engine apart from InnoDB. So those kind of limitations you may want to address uh, by changing the storage engine, right? So once you complete your assessment piece, you can decide about whether to go for online or offline migration. And if it's online migration, all you have to do is basically do the initial dump and restore. And once that is done, configure data and replication between your on-premise and Azure service. Once the data is replicated and intact, you can decide a timeline for your maintenance window based on your business requirements, and then do the failover and update your application strings. So we have a migration guide which is landed, which has like a scenario based learning approach with all the labs which are deployable with Azure ARM templates. It also has certain approaches for assessment and planning. It has the best practices for migration and testing and validation best practices, and what are the do's for post migration for success. So you can access this GitHub link and go through the migration guide uh, and review the migration framework, which explains about the pre-migration, migration, and post-migration. So some of the key takeaways for flexible server is you have your maximum control for your databases. You can build resilient apps across availability zones, and you have a simplified developer experience. It's a simple end-to-end deployment, fully compatible with MySQL community and PostgreSQL community editions, and easy cost optimization with start and stop and burstable servers, and co-locate your applications with the database in the same time zone and have your own custom maintenance windows. So one of the common questions that customer ask is when to use single server versus flexible server. So this is like a current comparison between single server and flexible server, and there are certain things which will come up soon in the flexible server. And since it's in preview, you will hear more about it once it's GA. So for example, if you want to have a custom controlled maintenance, you go for flexible server. If you want to have a zone redundant high availability and avoid any kind of availability zone level failures causing unexpected downtimes, that is the time you might opt for a flexible server. And also when I was talking about the read replicas, for single server, you can have up to 5 read replicas, and for flexible server, you can have up to 10 read replicas. So yeah, that is a lot of talking. So let me quickly show you some demo on the flexible server thing. So for demos, I'm going to do 3 demos. So let me quickly do that. So I'm in my Azure portal where I have one IaaS VM running in the Azure. I'm just connecting to my Azure IaaS VM using Bastion. And I already deployed one flexible server database, which I will be using for the demo purpose. But the first demo that I would like to do is let us quickly deploy Azure MySQL DB for flexible server, right? So I'm quickly going to create MySQL Azure DB. So when you go to Azure database for MySQL servers, if you see which one you are planning to choose, whether it's a single server or a flexible server, I'm going to go for a flexible server deployment. Uh, so So let's say I quickly create a flexible server or a resource group. Let's say create DPS, server name DPS demo. And then if you see here, it asks you what kind of workload you have. Based on the workload you choose, it automatically suggests you what kind of compute and storage you should look at, right? So if I say development, it suggests me burstable. If I say production medium size, it go for general purpose. If I say production large size, it will automatically switch you to optimize memory optimized. So for now, I'm going to choose development. So you can choose the availability zone. So you can choose a preference. You can say one availability zone, two or three availability zones. And then MySQL version, it comes in two flavors. Either you can go for 5.7 or 8.0 based on from where you are migrating your application and in the database. Um, so you can, as I said, I was talking about enabling the high availability. Once you enable the high availability, this will comes with a zone redundant high availability. You can either go for a same zone a high availability or a zone redundant high availability where your secondary would be deployed in a different availability zone. And then let's say you can give an admin user ID and a password to that. So once you give these options, now I was talking about the network access, right? You can either do a VNet integration using a private access and create your own VNet. If you see here, this is how the VNets get created. You can specify what is the virtual network and what kind of IP range that you would like to use. And then you can integrate it with your private DNS zone. Um, for now, for this demo purpose, I'm just going with public access, and I'm just saying allow this from any other Azure service within the same Azure server, and I'm just adding my current client IP address to communicate to the database service, right? So that is done. So you have configured the networking piece, and you can simply just create the flexible server. So now the deployment is in progress and it will start. If you see the initializing the deployment, it will show you how much would be the cost, the pricing details, and it has the submitting the deployment. So in the Azure portal, you can just see what is the status of your deployment, and you can download the deployment details, and it is still in progress. So this is the deployment name, this is the start time, and it's deployment is currently in progress. It takes like couple of minutes to complete, and once it's completed, your database is all ready to connect. So now let us go back to, so now I will quickly show you how can you do dump and restore and do like a quick offline migration to one of the existing database. So like I showed you, this is my, if you see, this is the Azure database for MySQL flexible server. This is a database which I created. So we are going to use this for the migration purpose. So I'm inside my IaaS VM, which is this. This is the IaaS machine. I'm inside the IaaS VM, and what I'm going to quickly do is Let's check if there is any database that is running in this IAS VM. So if you see, I do have a database, which is a MySQL database that is running here. So let's say I do a show databases, and these are the existing databases. So for our demo purpose, what I'm going to do is quickly create one database for DPS, DPS demo, right? Create database, DPS demo, database is created, and I'm just quickly going to create a table inside this database demo. So just let's say create table test. I have created the table, and then I just insert some data quickly, insert into, I'm sure the production databases are not going to be this small, but this is for a quick demo. I want to show you how you can do a dump and restore and quickly migrate, right? So now I have a database which is created for our demo purpose, which I'm going to migrate from your IaaS uh, server, which is running in Azure cloud, to a flexible server, which is deployed in Azure, right? So now let us quickly go back here. So I will come back. So for dump and restore, like you are aware, you can use MySQL dump, MyDumper for dumping the database. There are a lot of tools for the backup, but the best one that we suggest to use is MyDumper, because that is parallel thread. It's a multi-threaded, right? So I'm going to quickly change my directory to my backup directory location. So this is where I have my backup is created. So I'm going to just create a folder here, directly here, which is like, let's say DPS demo. It's created. Now let's get inside DPS demo. So all I'm going to do is now I'm going to take the backup of the database that we just created by using DPS demo, right? So this is the MyDumper command that you have to use while connecting. Since I'm connecting to the local host to take the backup, I'm not explicitly specifying the host. It would connect to the local host. Otherwise, you might want to specify the host name. So it is completed. Looks like there is something. Let us check. Let us quickly review the log. So cat MyDumper. Uh, logs.txt. Either it could be failed with some error. Okay, so looks like this is completed. I think we haven't changed the directory in the output directory. So my files will be in my data backup DPS. So let us go to the DPS directory and just do a lsrfnl. Yeah, if you see, we have the schema files created, and there is a metadata file that will be created, which will have your master coordinates, and it also has the data file for the table. So for each table, there will be a data file that is created and a schema file that is created. So if you see, you have your files listed here. So now what we did is we simply used MyDumper tool, and we connected to the MySQL that is running on the IaaS VM, and we took the backup, and now the backup is present in this location, right? This is the location where the backup is present. And what I'm going to do is now I will restore this backup to my flexible instance, the flexible server, which is this DPS Flex server demo. So once you deploy, this is how it will look like. So if you want to copy the server name, you just copy the server name from here, right? So once you copy the server name, I go here. This is the MyLoader tool, which I'm going to use to restore. And you have the database name, and then you just have to pass the directory which you the data directory was yes. Connect to this, and I'll go back here and so it's completed. The restore has been completed. To confirm this, what we can do is quickly you can connect to MySQL flexible server, where I'm specifying the hyphen host name, which is my flexible server database, and just okay. So looks like I gave a wrong password. Let's check that. Okay, so looks like there is some bug with my password. I will give me 1 second. I think it's changing. It's wrong here. Yeah, so now if you see I'm inside my flexible server, and if I just do show databases, I can see that my database TPS demo has been already replicated, already restored, and it's online, right? Now all I have to do is update my connection strings and start connecting to the new database. So this is like more like an offline migration. While if when you want to connect, when you want to do an online demo, all you have to do is you have to, after restoring the initial dump, you just have to configure data and replication between the source and destination. And once it is intact, you just have to do a failover. So we have a documentation with all the steps for the data and replication. So it says my deployment is completed, right? And you can simply go to the resource. So now let me just quickly show you the flexible server catalog, how it would look like. One thing is the built-in monitoring that comes up, where you have this CPU, memory, and IO that is monitored continuously, the database connections and the queries which are getting monitored. And in the compute and storage blade, you can, like I was talking, you can always increase your IOPS on the fly, and you just have to say save. The IOPS will be updated to the new value. Uh, for the connections, okay, and the connection strings, you can see there is no more @host name is specified in the connection strings. And the server parameters, like I mentioned, there is now a lot more control on the server parameters. It just takes some time to reload all the server parameters. Let me quickly talk about the replication. So this is the built-in replication that you can have, where you can create more replicas. As like I said, for flexible server, you can have up to 10 replicas here. You can add your replicas here. So simply you can say test demo and just create your replica, and this will be continuously synchronized with your primary. And in case of any failures, you can just make it as a standalone and bring it online. And then it comes up with inbuilt alerting mechanism. You have your own metrics, diagnostics, settings, and then the high availability part, where we were talking about enabling the high availability. Since I just have only one availability zone, I could not enable high availability, and this is because it's costable pricing tier, right? I was choosing development option, but you can always enable it once you are in general or memory optimized. So with that, let's go back. Uh, since this is a live session, if you have any questions, you can post it in the chat, and we will be here to answer your questions. These are some of the references for the existing MySQL documents. And thank you for taking time and attending the DPS Summit. It has been great presenting the session to all of you. And have a good day.